Go ahead.
Good afternoon, everybody. So today I'm going to take the course on Introduction to Mechanics of Materials. So what is mechanics of materials? Mechanics of materials can be defined as the branch of science that deals with the behavior of materials when subjected to force or displacement. Materials. Force or displacement. So we are dealing with the mechanics of materials. So I'll give you a brief introduction. What is force? Can anyone tell me? You can just read it and give your own idea. I just want the participation. That's it. It's it's okay if it is wrong.
Some action that changes anything, movement or even reaction.
Yeah. A force is an influence that causes an object to undergo a certain change, either concerning its movement, its position, or direction of the movement, or the geometrical construction. The shape will change. So, and force can be classified in the physics as two types: contact forces and the non-contact forces. A contact force is a force when there is an action if there is a direct contact between two bodies, like there is direct physical contact is there between two bodies, then it is contact force. A non-contact force is a force that results when two interacting objects are not in physical contact. We can say as the gravity, which we usually use. The earth is rotating, but there is a force acting on us. It is non-contact force.
May I ask you a question?
Yeah, sure.
The wind is a contact force?
The wind?
The wind, the force of the wind.
Yeah.
The contact?
Yeah, it's a contact force. Because there is the air particles are hitting us, then only we are getting the force. So it is a contact force. Next, we are going to the stress and strain. What is stress? I hope you understood what the force is. So the stress is related to force. Stress is force by area. Consider an object. So when we are applying force on this, the force applied per unit area, cross-sectional area, is stress. I hope you understood. So next is strain. Strain is the change in dimension of an object. I told you the force may cause geometrical deformation. So strain is we can say we are applying force on object. So the object may elongate. Suppose it elongates to this area. So let us consider as delta. So the strain can be defined as a delta by original length d. Is there any doubt? No. Next is normal stress. Next, the stress, we are applying the force. I told you about the direction also. A force which can be based on direction. We are saying it based on the direction. So normal stress, when an object is, consider an object of length L, and we are applying a force parallel to the axis of the object. So then the stress produced is known as normal stress. We will consider sigma is equal to n by a. N is the force, area is the area of cross section. I hope you understood. Yeah. Next is normal strain. The normal strain is related to normal stress. Yeah.
When you say like normal stress, like if the direction of the force is like at an angle, then the difference.
Yeah. There is another case. Shear stress based on the direction of the force only we are saying. Okay. Normal stress is the stress is parallel to the axis of the object.
Okay.
Another case, many other cases are there.
So this definition only applicable
To this, yeah, yeah, yeah. Next is normal strain. Normal strain is directly related to the normal stress. A normal strain is that strain. I hope you understood what is strain. A change, deformation in the object caused due to the application of the force. So a normal strain is the deformation in an object due to normal stress. So due to the normal stress, the rod will elongate in its longitudinal direction. Its length will change by a displacement delta. Strain is now defined as mu. Mu is equal to delta by L. Mu. It is the strain is represented as mu, and delta is the change in the displacement produced, a change in the deformation, and L is the original length. And there is a relation between normal stress and strain. We are using stress strain diagram. The relation between stress and strain is done using a stress strain diagram. It is usually a graph, and this is it is normally depicted as this. This is stress and this is strain, and the slope is directly considered as the E, the Young's modulus. So we are Young's modulus E. Young's modulus is then defined as stress by strain, and we are also considering the Poisson's ratio. Poisson's ratio is lateral by longitudinal displacement. Consider an object. If an object elongates, its cross-sectional area will also vary. Like if an object moves like is elongated in this direction, consider in a plastic bag, just a plastic lining. If we elongate it, there will be a difference in the cross section of the plastic. Have you noticed? Yeah, it is just similar to that. So the cross section, let us this is the lateral displacement delta, and this difference is known as longitudinal displacement. So the Poisson's ratio is minus of lateral strain by longitudinal strain. So this minus sign makes it positive. The value is always usually around 0.3. Any doubts? Yeah?
For any object, is it 0.3 or it's like for a certain object?
It's usually around 0.3 because because materials, based on the materials, the lateral and longitudinal, most of the objects have 0.3. Most, not all.
If you compare steel and the rubber,
yeah,
are they going to be both 0.3?
No, there will be slight difference, but it will be almost same. Like in the decimal values, it will be different, but we will consider the approximate value 0.3. It will be near to 0.3. Rod elongation. Let us suppose we know the dimensions A and L. A is the area, L is the length of the rod, and properties E is the Young's modulus, and loading conditions N is the force of a rod. Yeah, we can find the elongation. Delta equal to force into length by E by A. It's just stress is E equal to sigma by strain, stress by strain, but stress is equal to force by area into E, strain, but strain is delta by L. So we'll substitute this into this, so we'll get F by A into delta by into L E equal to, so delta equal to FL by AE. Right, you understood? I hope you understood. No response. We have, okay, and we can integrate the value delta using if you have a small, we are taking a small pot of length. If we are considering a rod of length L and we are taking a small distance between 2 points dx between the rod, we can find the delta in case for this rod, particular rod, and we integrate the whole thing. Integration, right? Understood? Next is shear stress. As you told, based on the direction, shear stress. Shear stress is a stress applied, that is applied perpendicular to the cross section of the object. Perpendicular to the cross section of the object. So it is, let's say, shear stress is denoted as tau, and it is tau equal to V by area of cross section.
So shear stress is when you have it perpendicular force.
Perpendicular to the area of cross section.
What happens if it is at an angle?
At an angle?
Force is at an angle, then we have to separate them.
Force is at an angle. Yeah, we have to find that. Suppose this is in a rod, and force is at an angle, right? Yeah. You're saying. So we have to find that theta, and we have to resolve it into two parts, and we have to do it. Next is, I hope you understood shear stress. Yeah. It is, everything is based on the direction. Stress is based on the direction. Or normal stress is at stress when the force is applied parallel to the axis of the object, and shear stress is a stress when the force is applied perpendicular to the cross section of the object. Understood, right? It's easy. Next is shear strain. Shear strain is a strain produced when shear stress is applied. Consider we are applying force parallel to the surface of the object, right? Earlier we considered rod, right? Now we are considering the cross section of the rod. This is a cross section of the rod. So the thing is, we are applying the perpendicular to the parallel to the surface of the rod, but perpendicular to the axis. So the thing is, there will be angular deformation in the object that will be there, like it will be there will be a small twisting like effect will be produced, small twisting like effect. So we are the shear strain is new. Shear strain is new. So we are, G is the modulus. G is equal to tau by nu, shear modulus, and we have an equation relating to the modulus of rigidity and Young's modulus, E equal to 2 into 1 plus nu. Nu is Poisson's ratio by G, modulus of rigidity. So I hope this is the full session. I hope you understood. Is there any doubts? We studied force, stress and strain, normal stress, normal strain, shear stress, shear strain. Any doubts?
Okay, let's give him a hand.
Thanks.